Okay guys, welcome to our channel, which is a learning channel for every student, university student, high school student, engineering. Every engineering student can find information in our channel. Okay, our channel is Mind of Intellectual. Please subscribe on the bottom so that you can get the notification when we uploading any video, and you can leave your comment on our comment section below if you have any question or you want us to do any example that you don't understand. Okay, today we are doing stiffness matrix method on a plain truss. So our example today is gonna be on the plain truss. I'm gonna also upload the video on for beams or other truss and any sort of stiffness matrix and flexibility, and we're still gonna upload a lot of example on structural analysis and a lot of subjects. We're gonna upload videos so that can help you. Okay, let's look at our example for today. So I'm gonna wait so that my screen, I'm sharing the PowerPoint so you can see it. So our example today, it's the structure shown in figure 2. This is figure 2. Is a hinge at the support. Assume EA for members. Use stiffness matrix method to determine the member stiffness matrix, structural stiffness matrix, displacement equilibrium matrix, and member forces. And they have marks here. Okay, I have pasted the formula here. We're gonna use, but I'm not gonna explain them now. But when we're going with the example, I'm gonna explain those formulas. You're gonna need all of them to do this example. Okay, please don't forget to subscribe. On the bottom, click on the right button below and leave your comment if you want us to clarify something on this question. Okay, let's start with our question first. I'm sharing my PDF. I hope you guys can see it. Okay, I have a draw that's 5 here so you can see. First of all, we need to determine the forces here. So we need to find the forces of these members here. So I have named my member. This is member 1, member 2, member 3. This is node 1 and 7 and 8. This is node 3 and 4. This is node 5 and 6. This is node 1 and 2. You need to name your node before you start your example. Okay, let's start with this. I have constructed a right angle triangle to get the angles here. Okay, if I have a right angle triangle, this right angle triangle here, okay, this is this side here. This side is 3 meters and this side is 4 meters. So to get, this is the right angle triangle. To get this angle here, we're gonna use tan, which is tan is adjacent over, no, it's tan is opposite over adjacent side, which gonna be tan 3 over 4 is written here. I got 3, then tan theta equal to 3 over 4, then I got theta as 36.86. 36.86, you can see here 38.86, and then I got this angle here, the angle inside here. I don't need this angle actually, I need this angle here, but on a straight line we know that angle make 180 degrees, so 180 minus 36.86, we got 143. So this angle here is 143.13. So if every triangle here are similar, so this angle here is equal to this one. So on the side I need this angle, which is 36.8, and then on here for member 1 I need this angle here, which is 143.13, as I got it here. Okay, the first step is we're gonna classify our truss. Okay, we have m plus r minus 2j. That is the formula to classify this truss. Okay, we have how many members? 1, 2, 3. We have 3 members. That's why I have 3 here. And then how many reaction? They say all reaction are pin. So we have 3. We have 2, 4, 6. That's why I have 6 here. Then 2 times how many joint do you have? 1, 2, 3, 4. That's why I have 4. Then we get 1, which means our truss is indeterminate to the first degree. Okay, first thing we need to have to start with our stiffness matrix is to find the length of the member. Let's start with member 1. Okay, member 1, we got that it's 5 meter long. How did we find that it's 5 meter? I use this Pythagoras theorem here, which say x squared equal to y squared. No, x squared plus y squared equal to r squared. Then I have my x as 4 and my y as 3, and then my r was unknown. Then square root of 3 squared plus 4 squared equal to 5. That's why I have 5 meter here. And then I have cos the angle for this member. For member 1 is 143 as written here. So I have to get cos theta, which is cos 143 1,13 equal to minus 0.8. I have, and then I have sine theta, which is sine 143.13, which is equal to 0,6. And then the first thing I need to calculate is k. K is equal to, this is the formula for k, which is cos theta. It's cos times theta minus cos squared negative cos times sine sine squared minus cos times sine minus sine squared minus cos squared minus cos times sine minus cos squared cos times sine minus cos times sine sine squared cos theta positive sine squared. Okay, then our cos squared is equal to, oh, the other thing here, remember we have EA over L equal to this cos here, whatever we have inside here. So our length is 5 here, so here we have EA over 5. So on our question they say EA is a constant, so you don't have exactly value of EA, you're gonna leave as EA. And then let's continue. Our cos is minus 0.8. So we have minus 0.8 squared times 1 over 5. Remember, we have EA over 5 here, which gonna have cos squared times 1 over 5. That's why you have 0.8 squared times 1 over 5, which is equal to 0.128 here. Then we have cos times sine, which is minus 0.8 times 0.6 times 1 over 5. Remember, don't forget that there is 1 over 5 on the outside here. Okay, then we continue. We have minus cos squared times 1 over 5. We have cos and sine here. So we constructed those values here. Okay, remember, we have like name our stiffness here because we have 7 and 8, 1 and 2. That's why we have 7, 8, 1, 2. It's member 1. This is member 1. This is member 1, and then it's from 7, 8, 1 and 2. That's why we have 7, 8, 1 and 2. And we have to write here 7, 8, 1 and 2. Okay, from there we have our K1. Let's continue to our K2. Okay, K2. We go into member 2. Member 2. Okay, we are on member 2. Our length gonna be similar. We're gonna use the same formula to calculate the length of member 2, and then on length of member 2 we have the angle of 36.87. Then we have cos times 38.7, which is 0.8 here, and then we have sine 36.87, which is equal to 0.6. And then we have the same formula to calculate the K2, which is cos squared, which is 0.8 squared times EA over 5. EA is a constant, so it means we're gonna times this by 1 over 5. That's why I have 0.28. And we calculated like as we calculated for member 1. So you can use your calculator to punch all those answers, and we have our K1. And then let's continue to our next slide. Okay, my slide have to pop up on your side. Okay, now we're on member 3. We're on member 3. Our member 3 is 5 meters long, and our data is 143.13. We got our cos theta, we got our sine theta. Then same thing, cos squared here times EA over 5 times 1 over 5. We constructed our K stiffness matrix. Okay, we name it 5, 6, 1 and 2. As this is member traits from 5, 6 and 1 and 2 not. Okay, then we continue. The next step, when we have our K value for all our members, we continue to get structure stiffness matrix, which is S. How to calculate S now? Okay, let's go to our slide 1 here. Where do we have the loads? Here we know that there is no load. There is no load here. There is no load here. But here we have 50. Okay, let's go on this side so you can see it. Okay, our load is we have 50 kilonewton, which is going to the left. We have 80 kilonewton going downward. On node 1 and 2, we name this as 1 and 2. Okay, let's go to this slide and continue. Okay, that's why we have 1 and 2 here, where we have the forces. The node where we have forces 1 and 2 and 1 and 2. Okay, we're gonna group. We'll be adding in every K value where we have 1 and 2. We're gonna add those values. For example, let's look at here. Let's check this one. Let's look at here. Okay, we're gonna group. Look at here. This one, it's Horizontally, we have 1 here, and also we're going to have 1 here, which is 1 is to 1. On member 2, we have 1 here, and then we have also 1 on the side. We can like name this as 1 is to 1, and then we're gonna add 1 is to 1 for member K1, and then we add 1 is to 1 for K2, then we add plus 1 is to 1 for K3, and then also for 2 is to 2, 2 is to 2, where 2 and 2 meet, we got 0.72, and also here where 2 meets we got 0.072. We're gonna add 2 is to 2 for K1, K2, and K3. That's where we get our S values. Okay, yeah, that's where we get our S values. We're adding like 2, we got 1 and 1, we add 1 and 1 from K1, K2, K3. 2 and 1, we take that value, we add from, even remember, if you have negative sign, don't forget that negative sign, use that sign to calculate your S. Then we add for 2 and 1, we add it from K1, K2, and K3, and also for 2 is to 2, we add from K1, K2, K3. Okay, that's it, guys. I hope you understand, and it's just simple. Okay, let's continue to our P, drawing load vector. Then our P is simple. My assumption, I assume that when you're going on the left side direction is negative, downward direction is negative. That's why I have minus 50 and minus 80. P is just like the force, those force on member on join 1 and 2. I have minus 50 and minus 80. And then from there, I have to contract a P equation which is equal to SD. Okay. Then my P, I calculated my P here. I've constructed my P here, which is minus 50 and minus 8 equal to, I have constructed my S here, which is minus 0.384. No, it's positive 0.384 minus 0.96 minus 0.96 0.216 equal to D1 and D2. And then I calculated my value of D1 and D2 here. You can calculate them. You can use like the stiffness method to calculate this. You can also use the simultaneous equation. You can like combine this one to calculate, to make them maybe simultaneous equation to find D1 and D2. And you can also use the stiffness method to find the value of D1 and D2. But if we have a problem with simultaneous equation or stiffness matrix, how to work it out, leave a comment on our comment section, and also subscribe to get our notification. We can like show, like maybe explain how to calculate the simultaneous equation, how to calculate the stiffness matrix to find D1 and D2, guys. Okay, leave a comment on the bottom so we can do the example on stiffness matrix or simultaneous equation. Let's continue to our next step. Okay, our next step is gonna find V1. V1 is simple, for course we have like on member 1, which is 7, 7, 8, 1 and 2. So it's simple to construct. We have 0, 0, 0. So for member 7, we don't have any force, so we have 0. For member 8, we don't have any force, we have 0. For member 1, remember we have a force That's why we have D1 here. We also calculated D1, and then on node 2 we have a force, downward force, which was, I think it was minus 80. That's why I have D2 here. Then we put 0 0, we put our value that we calculated previously for D1 and D2, and then we go to V. Okay, our V is equal to T. This is T, guys. This is T. Okay, this is T. This is V1. So our U equal to T times V1. Let's go to our formula here. I'm gonna just do it here. Okay, remember this is the formula for T inverse. This is the inverse of T. This is T. T equal to cos sine 0 0 0 0 cos theta, and then this is the value of K, which is 1 minus 1 minus 1 and 1. Remember those formula because we are using them to calculate everything. So let's continue. So we have here, this is cos sine 0 0, the formula for T. This is T and this is V. Okay, we have our cos is minus 0.8, and then our sine is 0.600. This is the formula. Okay, then we multiply our matrix stiffness, we get 0, and our U1 is 0, our U2 is 88 minus 88.542. We use like Stiffness matrix to calculate these values here. We get those answers. If you don't understand how to calculate the Stiffness matrix, you can, as there is like a genius calculator you can use to calculate your Stiffness matrix, and you can do it manually. But if you want to learn how to do it manually, you don't understand, leave a comment in the bottom. We're gonna do an example on how to calculate the Stiffness matrix. And don't forget to subscribe on our channel, so when you upload a video, you're gonna get the notification that we have in your video. Okay, let's continue. Now we're gonna calculate Q. Then Q equal to K times U, and then we have a formula for K. Remember, I showed the formula for K on that side, which was 1 minus 1 minus 1 and 1. So we have EA over 5 here, then we times 1 times 1 over 5, which is 0.2, minus 1 times 1 over 5 equal to minus 0.2. That's how we constructed this matrix here. And then we times that by U, which is, we calculated U here. This is our U. So we multiply K times U, we get 17.708 minus 17.708. We use matrix stiffness to calculate those values, and then from there we have F equal to T inverse of T times Q. Okay, I show you the formula for inverse of T times Q. Okay, we have cos 0 sine 0 0 cos 0 sine, then times Q. We have work out our Q here. Then we're gonna multiply those values and got these answers here. When we multiply this T inverse times Q, then we got our answers here. Those are the steps to do your matrix. Those are the steps to do your matrix for plane truss. Okay, let's continue. It's gonna be the same procedure, guys. It's easy. We're gonna do like the same procedure as if you understand what we did on member 1. We're gonna do the same thing on member 2. We're gonna find V, which is okay. We name our node 3, 4, 1 and 2. And then you don't have force on 3 is 0. You don't have a force on 4 is 0. Then on 1 we have force, we have T1, and then 2 we have a force is T2. Then we calculate, take those values of T1, those we calculated previously, we go with them. That's why we have them here. And then we constructed this T. This is T. This is T times V. Then our T is cos sine 0, 0, 0, 0 cos. Then we take, remember, on our first step for member 2, we calculated cos and sine. So we're using those cos and sine here. Then we're going to multiply our T times U and get our value here. Then let's continue from there. Then we calculate Q, which is Q1 and 2, and Q1 and Q2. Then we have, remember, we have this formula for, what was this formula for K? It's K times, what did you calculate previously? It was U. So it's K times U. Q equal to K times U. So this is our K and U. We multiply K and U, get 97.9165. Okay, guys, remember, because they tell us this EA is a constant, that's why we have EA times our value. Remember to put that EA to show that you have the constant. They didn't forget that we need to multiply this value by EA. A is the area of the member you are using. Okay, let's continue to our F2 for member 2. Then it's inverse T times Q. We put our values for K as we calculated on the first step times Q. It's times Q. This is Q we calculated here. This is this Q we calculated here. We put that Q here, and then we multiply those definite metrics. We get our values here. Then we get those values here. And then on member 3, we do the same thing. Remember to name your stiffness. It's 5, 6, 1, and 2. And then there is no force on 5 and 6. That's why you have 0. D1 and D2, we have 1 and 2. And we remember on a step we calculate D1 and D2. You calculate D1 and D2 like once, and then you use those values all over. And then also for cos theta and sin theta for member 1 and member 2 and member 3, you calculate a lot on the first step. And we're using those values everywhere here. On our formula, we're substituting cos and sine. Okay, then we multiply our C times V, and then we calculate Q3. We have this value. This is 1. This was 1 times 1 over 5 minus 1 times 1 over 5 minus 1 times 1 over 5, 1 times 1 over 5. And then we multiply our stiffness. This is U. We take our U from here, we multiply with this 0.2 minus 0.2. Then we get our answer as 17.7084 minus 17.7084. And then the next step, we find our F3 again, the inverse of T times Q. In F equal to inverse of T times Q. Then we take our inverse of T, substitute our cosine. Remember, for member 3, we substitute cos sine 0, 0, cos sine 0, 0. We multiply with Q3 here. Multiplying these different metrics, we got these answers here. Okay, let's go to our next step. This is our next step. Yeah. Okay, we are done calculating our forces. Now we can substitute on our forces that we have calculated. Okay, let's see, what did we get for member 1. Okay, for member 1 we have minus 14. Not sure if you can see, we have minus 14, 10, 14, and 10. And then we substituted this one here. We have Okay, 14 minus 14, we point it as, we have pointed that this 14 here. Okay, this is member 1. This is member 1. We go on member 1, you have 14 minus 14. See, it's pointing on the left because it was have negative sign. 10.63 is pointing upward. Why? Because we got that value from member 1 is pointing, it was normal, it was on with a positive sign. Let's go to member 2. On member 2, oh, this is 3. Where is our member 2? Oh, our member 2 is here. Okay, on our member 2, what did you get? On the first, we get 78, positive 78.33, and then 58.744, and we have minus 73.4 member 1 and 2. Okay, we have 78.33, 58.7499, and then this is member 2. We have positive sign. We take those first two values. Remember, we have positive 78. That's why it's pointing to the right, because on the right hand side we say right hand side positive, on the left hand side negative, and then we put our 58.758 pointing upward because it is positive. Let's go to our member 3 to see what did we get there. Member 3, take, this is for our forces, guys. Okay, let's see what did we get here. We got minus 14, positive 10. Remember, this sign means that this force is going to the left. Positive sign means it's going upward. This is horizontally and vertically. Horizontal, vertical. Even here on F2, this is horizontally and vertical. Horizontal, vertical. Okay, let's go and add there on our member 3. We have this is member 3. We got negative 14.17. That's why it's pointing to the left. We gave positive 10.63. That's why it's pointing outward. Okay, we have our forces. Then remember, we have like our external forces, which is 50 and 80. And then let's check if our truss is correct now. We're using like the sum of vertical force equal to sum of downward force, which need to be equal to 0, and sum of force which going, sum of horizontal force equal to 0, which you're gonna equate when force is going to the left, and left forces that are going to the left must be equal to the force that are going to the right. Force that are going upward must be equal to the force that are going downward. Okay, let's check if we calculated our forces correctly. Okay, we have 10.63, which is going upward, and then we have our this 10.63 and 10.63 here, we are going upward. We have 58.7 going upward, and then we have minus 80, which is going downward. We got 0.01. Therefore, they are balanced. You can say that this is 0, can round off this into 0. Therefore, our vertical forces are correct. Let's check our horizontal forces. We have minus, okay, we have 14.17, which is going to the left, 14.17 going to the left, and then we have 50 going to the left, then we have 78.33, which is going to the right. Okay, I think the mistake we have here, we just mixed the sign. So this 14 was supposed to be negative, and this 14 was supposed to be negative, this was supposed to be negative, but this is supposed to be positive, but it doesn't matter. So we're going to get the same answer as 0 here if we swipe the answers. So now we know that our truss is correct. We have our forces here. So I hope guys we have understand our example here. Let's do our smaller recap. What did we do? Okay, we have our formula here, which is for tk and t lambda. Let's just go here. First thing, we calculate our t. No, we find the length of the member, and then we cos theta sin theta, and then we use this formula to calculate k1, k2, and k3. From there, when we have our k is different matrix k1 and k2 and k3, and then we find our s, adding those coordinates 1 and 1 from member 1 and 2 and 3, and then we add 2 and 1 for member 2, for member 1, 2 and 3, and then we constructed our p, which is joint dot vector, which is we just like have our forces on the truss, external forces. And then after that, we have our P equal to SD. We have P as we constructed here, and then we have C as we calculated here. Then we have D1 and D2, and then we use simultaneous or step methods to find the value of D1 and D2. And then next step from there, we go to every member from member 1 and member 1, 2, and 3. We find the value of V, then the value of U, value of Q. Okay, for value of U, we use T times V. V we just constructed it using D1 and D2. And then for U1, it's T times V. It's T1 times V. Then we multiply with different methods to get these answers here. And then for Q1, we multiply K times U. We have like on the slide, you can check on the slide, we have K formula and U formula. Then we calculate our different metrics, and then we calculated our forces. To calculate our force, we have T inverse times Q. We have our Q here, and then we have formula for T inverse. Then we put our cos and sine, cos sine. Then we multiply our T inverse by Q. Then we get our force values, and then we follow those steps for member 1, 2, and 3. Then calculate our forces here. It's just simple as that, guys. I hope everyone understand. If you have any question, go at the bottom and leave your comment there if you have any question about this example, or you want us to do any other example. And also don't forget to subscribe on our channel. If you are subscribing, it's free. You won't pay anything, you won't be signing anything. You just subscribing so that you will be notified when we uploading like a new video on our next example. So guys, thank you very much for watching this video. I hope it was helpful, and if you have any question, just comment, go to our comment site and comment there. If you have a question, post the question there, we will answer your question on the bottom. Okay guys, good luck on your course. I hope you're gonna succeed. I hope this video was helpful. We're gonna post a lot of videos, guys, so please subscribe so that you will be notified if we're posting any new video. Okay guys, thank you very much. Good luck on the course. Okay, we're gonna see you on our next video shortly. Okay, thank you very much, guys.